My name's David Walker. I'm a Director of Environment and Major Infrastructure at Stantec, and therefore I'm responsible for our team of specialists who are involved in the environmental assessment of major infrastructure planning, land development projects, which obviously more and more includes working with our buildings colleagues in the structural and buildings departments, and undertaking carbon assessments, carbon reduction assessments, embodied carbon assessments, etc. I'm also lucky enough to be working quite a significant amount of my time on the High Speed 2 rail project at the moment, which obviously being one of Europe's biggest infrastructure projects and one of the biggest construction projects in Europe at the moment, there's a huge focus on carbon, embedded carbon and carbon reduction.
It's a shame the focus wasn't on keeping it within budget.
No, I'm joking.
Couldn't possibly comment on.
Okay, so let's delve into some of the important discussion points now. So could you enlighten our listeners on the concept of embodied carbon in buildings and its significance within the construction industry?
Yeah, sure. Embodied carbon is essentially a term used to describe the carbon that's emitted in the construction of buildings, the construction of the materials or the production of the materials that go into buildings, the transport associated with those materials to and from the building site, their manufacture. And the construction industry is responsible for a significant amount of carbon emissions because of the nature of the materials that go into buildings. So, for example, concrete manufacture and cement manufacture are very, very high energy intensive production processes. And therefore, in those production processes, a lot of carbon is released. And that's what is reflected in the term embedded carbon. Also, buildings contain glass and other materials as well, which are also intensive in terms of carbon production because they use a lot of heat in their manufacturing processes. And also with our global industry, with a focus on more global production and manufacture of materials all over the world, transport costs are quite significant as well.
Perfect. So when it comes to embodied carbon, what are the primary factors contributing to its high presence in the building materials and systems?
Well, I would say the first, as I've already said, is the energy intensive manufacturing process. So a lot of energy is used in production of certain materials, and that includes obviously carbon, etc., glass and that sort of thing. Extraction process is very energy intensive, particularly where you're looking at the extractive and minerals extraction industry to produce aggregates and then transport them to the point of use on the building site and also to the point of manufacture. Just transportation generally, long distance transportation obviously uses energy in order to move things from A to B, and we're still very heavily reliant on fossil fuels for heavy transportation, and obviously there's carbon emissions associated with the combustion of fossil fuels. And also to a degree, certain construction buildings and certain buildings as they're constructed have a relatively short lifespan. So we're not necessarily always focusing on longevity and the ability to repurpose and refurbish our buildings. And that means that all of these factors, including the embedded carbon which go into constructing those buildings and premises in the first place, often aren't repurposed. And so when the buildings reach the end of their life, or if the buildings aren't particularly high quality, after maybe 10, 15 years, they tend to be demolished. And there's challenges with reusing those materials. They can't always be effectively recovered from the demolition process. And that means obviously then in the construction of new buildings, we therefore have to use fresh materials, and that releases more carbon.
Indeed. Okay, so as we strive to address embodied carbon, what are some of the effective strategies that the construction industry can employ to reduce its presence throughout the building life cycle, encompassing material selection and construction practices, for example?
Well, I think you've touched on two of the main areas where there's opportunities, and material selection is certainly one of them. There are low carbon concretes being developed, and other hybrid materials which include reduce the amount of carbon, I should say, that's used in the production process rather than traditional concrete. So there's a lot of work to do there, and also producing new materials such as building systems from recycled materials. So those are one of the things. But of course, the building industry, with new materials come risk. And there has to be a balance between where that risk lands, because constructors and construction companies are not going to be willing to take the risk of using innovative new materials unless the longevity and resilience of them has been proven, particularly in a project such as HS2, which has got a design life of 120 years. The risk has to be shared between HS2, the project, and also our contractors if they're proposing to use new materials. And then I think engineered timber is an area where there's quite a lot of opportunity for using more of that. The technologies that go into and the structures and the strength of the structures that can be produced using engineered timber and laminated timber products is significant. And because they're made of wood, that means the carbon has already been sequestered into those, so it's embedded in them and it's been taken out of the atmosphere during the growth of the trees that have been used to produce that timber. And I think also the focus on reducing those short lifespan buildings as well, thinking about designing buildings for a long-term service so that they can be repurposed, they can be retrofitted, internal layouts can be changed, and floor plates and the spacing of floors and other elements of those buildings allows them at a future point to be repurposed and easily refurbished if necessary. So I think there's quite a few areas there where there's opportunities, and we see those opportunities being delivered in quite a number of examples that I've worked on in the past now. The industry is innovating in this area all the time.
When you say it's innovating, there can become a problem, and there's an argument at the moment for carbon to have something that's more carbon efficient, but then you can also take away from fire safety on that.
This is probably an example of some of the challenges the industry faces. For me, obviously with tragedies such as Grenfell still very much in the minds of the public and the inquiry is still ongoing, the focus on fire safety in the design of our buildings and where there's been possible failures to take sufficient account of that in the past are all too clear. And so there's always got to be the safety of buildings and the intrinsic safety of materials has always got to be the top priority. But I think that the industry does innovate, and if the demand is there, and demand is being driven by regulatory pressure, but also by pressure from institutions such as pension funds, which often finance the industry and construction in order to comply with their own environmental management credentials and corporate and social responsibility, are forcing innovation and driving innovation. I don't really see any reason why it shouldn't be possible to achieve low carbon and low embedded carbon materials, more lightweight materials as well, without compromising fire safety.
Perfect. So you touched on concrete earlier. So concrete often faces scrutiny due to its high embodied carbon. Could you share your insights on concrete and why concrete presents such challenges in terms of both embodied carbon and reuse?
Well, there's two reasons. One of the reasons why concrete has such a high embedded carbon, high levels of embedded carbon, is because its production is very, very intensive. So, and it's heat intensive. A lot of heat is required in order to convert the limestone into cement, and obviously cement is a key component of concrete. Again, the generation of the heat necessary for the process relies on fossil fuels, and we still produce concrete in that way, and therefore that's a significant component of carbon emissions and embedded carbon. Very often concrete components are manufactured off-site, perhaps some distance away from the point of use. Prefabricated components may be manufactured overseas and shipped to the point of use. And therefore, because of their weight and because of their size, transport can be inefficient. It can take a lot of transport movements to deliver all the components necessary to complete a structure. And that transport emits carbon during the transportation process. And then traditionally, the way that concrete is used in buildings at the end of use makes it quite difficult to separate the concrete from the other structures of the building, which means that the aggregate and the recovered aggregate at the end of the recycling and the demolition phase is often of low quality because it's contaminated with other materials, plastic, steel, reinforcement, etc. And therefore it doesn't lend itself to being recycled into new product, or certainly new product of a sufficient quality to be reused in a structural capacity.
So you touched on it earlier when you were speaking about concrete, but considering limitations of concrete, are there viable alternatives that possess lower embodied carbon and offer improved sustainability in terms of reuse?
Well, obviously this depends on where they're being deployed in the building, but I touched on laminated timber as being one area which is increasingly being used for building construction. That's an area where for certain types of building it's very effective, and it allows for high-speed, lightweight buildings to be constructed fairly quickly. The strength of the structures is there. But obviously that introduces other challenges in terms of the way the building performs in terms of insulation and thermal performance, etc. So one of the other things that's quite interesting is structurally insulated panels, which are composite panels which have a strong rigid outer skeleton and then an insulated material on the inside, and they're being used more and more in buildings as well in order to provide the necessary structure and insulation and thermal performance to the buildings, but also to provide the strength. And it's how these buildings are designed so that these form part of the structural exoskeleton of the building and actually provide the structural strength, rather than relying on more traditional concrete and steel structures.
Okay, so with the role you do, you're probably perfectly placed to answer this question. Are there any innovative approaches or technologies that can aid in the measurement, tracking and reduction of embodied carbon within construction projects at the moment?
So building information modelling software is a key component. It's used extensively in my industry, both in the design and execution of building construction. Carbon tracking products and software, which tracks different types of production methods throughout the life cycle, allows a benchmarking and comparison of traditional material and construction methods against more innovative measures. But in terms of materials, there's progress being made on low carbon concrete, which uses different kind of energy sources and different production methods to produce the concrete. That's been increasingly used in the construction industry, and other things, as I've already touched on, such as the integrated panels and cross-laminated timber. And in certain situations, you can use things like rammed earth and straw bale construction for buildings as well. And there's a lot of research going on into those. Obviously not necessarily suitable for certain building construction or certain environments, but it's a case of understanding where these techniques can be applied. We've been doing it for hundreds of years, building houses out of cob and straw. So it's scaling that and applying the technologies that the industry now has behind it to make sure to develop products that will work on a commercial scale and work under the kind of demands that we need them to, in order to create the built environment that we need as in our cities and towns.
Indeed. Okay, so drawing from your experience, can you provide any examples or case studies where significant reduction in embodied carbon has been successfully achieved?
Well, I think I'm going to turn to HS2 and my work on HS2 in that regard. And one of the biggest areas where we've managed to substantially reduce embodied carbon is during our construction processes at a site we know as the Chilterns Tunnels, where HS2, as it comes out of London, passes up the Colne Valley, the River Colne Valley, and under the Chiltern Hills, and then continues its journey north up through Buckinghamshire and Oxfordshire on its journey up to Birmingham. And anybody that's travelled on the M25 from the M40 junction round towards the M1, if you take a look to your right as you travel round in a clockwise direction, you'll notice that there's an enormous construction site there, and that is essentially the launch site for the tunnel boring machines that are drilling the 2 tunnels through the Chilterns. And an awful lot of work has gone into identifying where the savings could have been made and can be made in terms of carbon, embedded carbon and bodied carbon in that process. It's an enormous construction process. The tunnels are lined with concrete, prefabricated concrete units, thousands of them, and traditionally these would have been manufactured off-site and brought to the site, unloaded from vehicles, so thousands and thousands of vehicle movements to bring those to the site, transported and loaded up onto the tunnel boring machines, which then use them to line the tunnels as they progress underground.
So just throw another question in there now. So we're talking about trying to make buildings more carbon efficient and bring down the embodied carbon. Kind of throwing a spanner in the works when we have to put a second staircase in. That's actually adding in more concrete, which will increase the carbon of the embodied carbon.
Yeah, so I guess that kind of underlines the default mindset that we need to overcome. The immediate assumption is the staircase has to be made of concrete. Does it need to be made of concrete? Can it be made of other materials, composite materials? Are there lower carbon steel, recycled steel, etc. that could be used? Obviously, the staircase has to perform to certain standards in terms of fire protection and resilience, but this is where that sort of default setting, we've been asked to put a separate staircase in, a second staircase in, it needs to be concrete. It's about changing mindsets and giving designers and engineers the confidence to be able to draw from a wider range of options.
Do you think concrete is usually the go-to because it is slightly cheaper than other materials out there?
I think it's like many things. I think concrete is it's been the material of choice. There's a very, very well established supply chain. There's a lot of stakeholders involved in the extraction industries associated with the concrete business, the manufacturing business, and frankly there's an awful lot of money associated with that. So the desire and the momentum behind it in just the same way as the fossil fuel extraction industry is a very well established industry. There's a lot of momentum that has to be overcome to move away from that. But the concrete industry also recognises that, and it is doing an awful lot to innovate and develop new materials and work on lower carbon products which are less energy intensive in their production, include a greater proportion of recycled materials, and obviously maintain the same performance characteristics of concrete.
Okay, so in your perspective, what specific challenges or barriers must be addressed to accelerate the adoption of low carbon practices and materials within the construction industry?
I think you've touched on them already, Dom. I think you touched on the fact that concrete is cheaper, and I think the perception that lower carbon alternatives or low carbon buildings are more expensive, don't perform as well in terms of their thermal performance, or don't last as long, don't have such a long lifespan because of the nature of the materials, and just a perception that a building that's got a structure made of cross-laminate timber rather than steel can't be as strong or can't be as good. So those are the sort of perceptions that need to be overcome, and the only way that can be overcome is by using these materials, specifying them more, developing buildings with them, researching into their performance and learning from incidents where things don't go to plan, and overcoming these mindsets which obviously default towards the tradition and what's well known because it's the easiest. And with everything, I think the economies of scale will also bring down prices. So the more materials that are used, more of these innovative materials that are used, then the manufacture of those materials will upscale and therefore costs per unit will decrease.
So looking ahead, what do you envision the future of embodied carbon reduction in the construction industry, and what steps can be taken to further develop this process?
I think there's a lot of opportunity there, and I think that as is the case with so many examples of this sort of thing, and environmental management and increasing environmental performance or improving environmental performance, there's a combination of stick and carrot. So regulatory measures to require buildings to perform better in terms of their carbon use and their carbon emissions. That's something that government needs to focus on. It needs to present well thought through and attainable but stretched targets for how our building stock is developed and how we renew our building stock to improve its carbon performance. We need to avoid and move away and ensure that the industry doesn't become caught up in what's known as greenwashing, where there's a lot of carbon schemes have been set up and carbon reduction schemes and carbon offsetting schemes have been set up, which have been which many organisations have signed up to in quite innocently in the belief that they are legitimate, and they haven't always been so. They haven't always delivered what they've promised to, and of course that will erode confidence in those schemes and confidence in the carbon offsetting and carbon management industry generally. So I think there's work to do on that to tighten that up. And finally, I think more research and more innovation, and as I said before, as I touched on earlier, I think it's down to projects, it's down to huge large-scale projects such as HS2, which have got government and treasury backing to drive this innovation, to demonstrate that these new materials can be used, they can be deployed, to share the risk, to bear the risk of that innovation and that research with the contractors and with the industry, to demonstrate that actually there are alternatives, and to provide to pump prime the industry and the manufacturing and construction industry and transport industries to upscale and start focusing on these and delivering them in greater quantities with all of the benefits that I touched on, such as price reduction and ease of use and speed of construction.
You really shared some invaluable insights there, and the expertise on embodied carbon and challenges posed by concrete in achieving sustainability. So thank you very much for joining us today on Construction Conversations, the ResiBuild podcast. Stay tuned for more thought-provoking discussions that shape the future construction industry. Thank you very much indeed, David.
Thanks very much, Tom.
Brilliant.
Thanks for having me.
Brilliant.
It's been a pleasure.